Hi guys, on this video we're going to discuss two things as we continue our discussion in distillation. First, we're going to talk about the phase equilibria for binary system, and then we're going to identify the components of a typical distillation diagram. Okay, so as we have learned previously sa ating mga chemistry lessons, we are already familiar with this illustration, which is a simple distillation set up in our laboratory. But in chemical engineering, if you look at the diagrams in our distillation or separation processes, you will find a typical diagram like this. Okay, so it is very important, therefore, to properly identify our components in our distillation diagram right here as compared to our distillation setup in our chemistry course. Okay, so iisa-isahin natin yung mga components dito sa ating distillation diagram. But of course, since this is the first discussion that we're going to have for distillation, we're just going to identify the typical parts, compared to this setup. But before that, let us discuss first about the phase equilibria for binary system in distillation. Well, let us say we have a closed container as what you can see here. And this binary system is composed of a liquid solution. So let us say this is our liquid solution having component A and component B. Okay, so meron lang tayong dalawang component because this is a binary system. Now we're going to identify these two components because as we have said dito sa ating distillation, we are able to separate the components of our solution due to their differences in volatilities, di ba? This is what we learned in our introduction to distillation process. Okay, so now we're going to separate this or identify these two components based from their volatilities. Okay, so magkaiba yung volatility ng ating component A and our component B. So of course, isa sa kanila is mas mataas ang volatility at ang isa naman ay mas mababa ang volatility. So let us say our component A is our more volatile component. Okay, so let me write that here, more volatile component. And of course, yung component B natin is mas mababa yung volatility. So we're going to call that as the less volatile component. In textbooks, you will see that more volatile components is also written as MVC or more volatile component. And the less volatile component is, on the other hand, called as LVC or the less volatile component. Now, it is very important to identify that when we are dealing with distillation. Kailangan malaman natin, alin ba sa components natin dito is yung component having higher volatility and component having less volatility. So, basically, our more volatile components or MVC are those having higher vapor pressure. So let me write that here. So they have higher vapor pressure. So mas mataas yung vapor pressure niya compared with the less volatile component. And also they have a lower boiling point. Okay, so compared sa ating component B, yung boiling point ng ating component A or MVC is lower, Of course, contrary yan dito sa ating less volatile component. So, our less volatile component have lower vapor pressure and they have higher boiling point. Okay? So, yan yung i-determine natin mamaya dito sa ating mga diagram sa itaas, But let us first explain itong ating phase equilibria for binary system. So, we already identify yung components natin. We have a more volatile component and we have a less volatile component dito sa ating binary system. Now, if this liquid is partially vaporized in a closed container like what we have here, where the total pressure is maintained constant, so let's say our pressure here is constant. The vapor and the liquid will ultimately be in equilibrium with each other. So through time, our vapor and our liquid will be in equilibrium. Now, it is very important in the study of distillation. The concentration of our MVC and the concentration of our LVC, both in the liquid phase and on the vapor phase. And in most references, you can see that, let's say if X represents the concentration of the MVC, our more volatile component in the liquid phase, then Y will be the concentration of the MVC in the vapor phase. Okay? Well, we're going to use this kapag nag-start na tayo ng ating mga calculation or further explanation sa ating distillation topic. Now, applying yung Gibbs space rule, we will be able to identify yung ating degrees of freedom, no? Dito sa ating binary system. So, we have a separate video about the Gibbs space rule if you want to review about that. Okay, so we're going to apply that here. So, we have our Gibbs space rule, which is our degrees of freedom is equal to C minus P plus 2, which C stands for the component, P for the number of phases, and we have to add it by 2 in here, no? So, we have a binary system here, so therefore we only have 2 components. So, our C is equal to 2. Then, minus our P, which is the number of phases. So, as you can see, we only have 2 phases here. We have the liquid and vapor phase. So, we have here minus 2 and then plus 2. So, therefore, our degrees of freedom in here is equal to 2. So, what does it mean? It basically means that if the pressure and the temperature are specified, so therefore given ang ating temperature and pressure, then the concentrations X and Y becomes fixed. So ito yung tinutukoy natin dito, yung X and Y, the components or the concentrations, no, dito sa ating system. So in that case, if our temperature and pressure are specified, our X and Y becomes fixed. Okay, kaya nako-compute natin yung ating components in our distillation processes because we have this condition, no? Our X and Y becomes fixed whenever our temperature and pressure are specified. Now, this data is referred to as VLE, okay? Which is the vapor-liquid equilibria. Alright, so alam na natin yung more volatile component and the less volatile component, no? As per our discussion dito sa phase equilibria for binary system. Now, we're going to identify that dito sa ating diagrams. Okay, so we already know about the setup, the simple distillation setup na pinag-aralan natin sa chemistry, no? But let us identify muna yung mga parts para hindi tayo mahirapan, ano? So, we know that this is our thermometer. We have our distilling flask here. And it contains our solution that we're going to separate now. And then our condenser. And dito sa ating condenser, we have our cooling water coming in here. So, cooling water in. And we have here our cooling water out. And of course, our receiving flask kung saan nako-collect natin yung ating distillate. Okay, so this is the parts of our simple distillation setup sa laboratory, di ba? Now, in our distillation diagrams in chemical engineering, you will find this as a typical example, no? Well, this is the solution that contains our components A and B if we have a binary solution like this one, no? So, in here, we call that a feed. So, dito manggagaling yan sa ating feed. So, ito yung pumapasok dito sa ating distillation column. And as you can see, we have two products in here. meron tayong product na lumalabas dito, and meron din tayong product na lumalabas dito sa ibaba, di ba? So, we're going to identify that. So, let us call this as the upper product. And then we have here our bottom product. So, dito sa ating simple distillation column, we have a condenser. So, in this diagram, our condenser is this one. So, alam na natin yung purpose ng ating condenser. We are cooling down itong ating vaporized na solution dito. So this actually functions the same. Okay, so we have our condenser here para yung ating vapor here will be liquefied. So, if that's the case, so dito, after natin ma-liquefy yung ating vapor, we are collecting the distillate. So, that means in here, okay, yung product natin dito sa upper product is our distillate, So, this is our distillate. Now, how about this bottom product? Ano yung mga nandito sa bottom product? Well, if we consider this again, okay, dito sa ating setup. So, let's say we have component A and component B in here. So, let's say we have A and B. And then, we are able to separate yung ating more volatile component, yung MVC natin. So, we are able to collect our MVC right here. Of course, may iwan dito yung ating less volatile component. Okay, so in this case, napaghiwalay natin yung MVC at yung LVC. In our distillate, we have the more volatile component, and in our distilling flask will remain yung less volatile component. So, it will be the same on this diagram. Dito sa ating product, we have our distillate which is rich in more volatile component. And dito sa bottom product, we have our liquid which is rich in low volatile component or less volatile component. Okay, so this is rich in LVC. So if our product is called the distillate, our bottom product is sometimes called as bottoms or residue. We also call that residue sometimes. So these are the components of our distillation diagram. Okay, so marami pa tayong parts dito na pwedeng pag-usapan in the future, pero we will stick with this one right now because i-discuss pa muna natin yung iba't ibang types ng ating distillation processes, Like for example, in here, we have our reflux and we have our reboiler. So, we're going to discuss that in the upcoming lectures, But for now, kailangan lang natin ma-identify kasi kung nasaan ang ating more volatile component and the less volatile component. Because it will be very important sa mga susunod nating discussion. Okay, so I hope na naintindihan na natin ngayon yung mga parts ng ating distillation column right here. So this is all for now, guys. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.